Congratulations to you or anyone you know writing JAMB this year 2025 for coming in contact with this channel. Congratulations. Now I want to solve problems, physics JAMB problems, to prepare you for the exam. I'm going to show you the difference between how WAEC asks question and how JAMB asks question. If you want to score 300 and above, please make this channel your best friend this period of exam. Look at this interesting question from physics JAMB past question. The density of a certain oil on frying becomes 0.4 kg per meter cube with a volume of 20 meter cube. What will be its initial volume when its initial density is 0.8 kg per meter cube, assuming no loss of oil due to spillage? How will you tackle this kind of problem? To tackle any problem given, let's write out all the parameters we are given. Given from the question, we are given the density of certain oil on frying becomes 0.6. It means density rho is 0.4 kg per meter cube. That's the density given with a volume. At this density, there is volume of 20 meter cube. What will be its initial volume? If we are looking for initial volume, let's call the initial volume V1. It means that the other volume will be V2 and this density will be rho 2. What will be its initial volume when its initial density is 0.8 kg per meter cube? Assuming no loss of oil due to spillage. If there is no loss of oil, it means that the mass remains the same. The mass, you see where you have to relate a common term, that's the constant. And remember that density rho is equal to mass over volume. Density is mass of a substance compared to volume. So if there is no loss, it means that the mass is constant, m is constant. And if m is constant, what do? We can cross multiply this and have that m is equal to density times volume. M is equal to density times volume. So we can go ahead and have it, since mass is constant, density 1, volume 1 is equal to density 2, volume 2. This is what you will use to solve this particular problem. Now make V1 the unknown, the subject of the formula, so that V1 will be, you divide both sides by rho, that's rho 2 V2 over rho 1. That is all. Then you input your values to get the volume we are looking for. Rho 2 is 0.4 times volume 2 is 20 over the density 1 is 0.8. So let's go ahead and divide. 0.41, 0.4 will give us 2. So 2 here is 1, 2 here is 10. Therefore, the volume we are looking for, the initial volume, will be equal to 10 meter cube. So you check which option gave us 10 meter cube. Hope you enjoyed the first JAMB question. Let's go to the second question. The second question, note that the change in temperature for theta P, we are comparing to P and Q. is equal to change in temperature for Q. And then the ratio of linear expansivity for P over the ratio of linear expansivity for Q is giving us 2/3. Then the question said we should find the increase in length of P to increase in length of Q. That's the question. So with this in mind, how do we solve this problem? JAMB will always look for ratio difference. Babies, why they will just tell you, linear expansivity is increase in length per original length per degree rise in temperature. But now JAMB is asking you for ratio, and that is how the pattern of JAMB is. It's always in such a way that the things can cancel out. You don't really even need a calculator. So let's go and let's solve this using that this for Q is equal to increase in length for Q over original length. Let's use LQ for the original length. Then the change in temperature for Q. That means that the increase in length for Q will be linear expansivity for Q times original length for Q times change in temperature for Q. And it's the same thing for P. Linear expansivity for P times original length for P times change in temperature for P. So since what we are looking for is change in LP over change in LQ, we can go ahead and say change in, that's alpha P times LP times change in temperature for P over for Q times LQ times change in temperature for Q. And remember that from the question, ratio of this is already given. Since it's multiplication, is already given 2/3. Then this and this, they are equal from the question. They can cancel out. And then another ratio that is given is this, 3/4. So let's put in all the values. If we put in all the values, what we are looking for, the increase in length, the ratio of the increase in length will be ratio of the linear expansivities was given as 2/3. 2/3 times this also, since it's multiplication, it will go, and the ratio was given as 3/4. And remember that this change in temperature, they are the same. Then 3 will cancel 3. Therefore, the ratio we are looking for, 2 here 1 and 2 here 2, is 1/2. 1/2. Hope you enjoyed this video. Please give it a thumbs up and share it to someone writing JAMB this year. See you in our next class.